Welcome back to Learn Civil Easy. This is the Saturday solution video for the Module 2 MCQ practice paper, Sewage and Drainage Quantity. Let us go through all 15 MCQs and both short answer questions. Question 1. Harmon's peak factor for a town of 1 lakh population. Harmon's formula is 1 plus 14 divided by the quantity 4 plus square root of P, where P is in thousands. So P equals 100. Square root of 100 is 10. Peak factor equals 1 plus 14 divided by 14, which is exactly 2. The answer is B, 2.00. Question 2. The sewage flow factor, also called the return factor, for a fully plumbed Indian city. Typically 0.7 to 0.85 of the water supply returns as sewage. The standard design value is 0.80. The answer is C. Question 3. Minimum self-cleansing velocity in a sanitary sewer at minimum flow. The standard value to keep solids in suspension is 0.6 meters per second. The answer is C. Question 4. Ratio of maximum hourly to average daily flow for a sewer line, that is the peak factor. The typical design value for an Indian town is 3. The answer is C. Question 5. The rational method formula Q equals C times I times A divided by 360 yields Q in cubic meters per second when I is in millimeters per hour and A is in hectares. The factor of 360 exists precisely to convert hectares and millimeters per hour into SI cubic meters per second. The answer is B. Question 6. Time of concentration of a catchment is the time taken by water from the most remote point to reach the outlet. It is the critical duration used for design rainfall. The answer is B. Question 7. Runoff coefficient for an asphalt pavement in good condition. Asphalt is nearly impervious, about 0.7 to 0.95. The closest standard value is 0.85. The answer is C. Question 8. Babbitt's peak factor formula, the form is 5 divided by P to the power 0.2, where P is population in thousands. Note option A is Harmon's, option C is Fair-Geyer's, and option D is Dickens' flood formula. The answer is B. Question 9. Dickens' formula Q equals C times A to the power 3 by 4 is applicable to flood discharge in North and Central India. Rive's formula is for the South India coast. Inglis is for the Western Ghats. The answer is B. Question 10. For a sanitary sewer, the design discharge is maximum hourly flow plus infiltration. Average flow alone is too small. The sewer must carry the peak. The answer is B. Question 11. In the rational method, the design rainfall duration is taken equal to the time of concentration. This gives the maximum runoff because the entire catchment contributes simultaneously. The answer is B. Question 12. As population P approaches infinity, Harmon's peak factor tends to 1 as square root of P grows. 14 divided by 4 plus square root of P approaches 0, so PF approaches 1. The answer is B. Question 13, which is not a source of sanitary sewage. Roof rainwater, when correctly connected, goes to the storm water sewer, not the sanitary sewer. Domestic, hostel, and hospital wastes are all sanitary. The answer is B. Question 14. Recommended return period for a major stormwater trunk drain in a metropolitan city. Residential drains use 2 to 5 years. Major trunks need 25 to 50 years. The answer is C. Question 15. In a combined sewer during heavy storm, the sanitary contribution to the combined peak is only 5 to 10%. Storm flow can be 50 to 100 times dry weather flow. The answer is A. Now to the short answers. Short answer 1. Peak factor formulas for population 50,000. Harmon's 1 plus 14 divided by 4 plus square root of P Babbitt's. 5 divided by P to the power 0.2. Fair-Geyer 18 plus square root of P divided by 4 plus square root of P equals 50. Square root of 50 equals 7.07. Harmon's gives 2.27. Babbitt's gives 2.29. Fair-Geyer also gives 2.27. Babbitt's is the most conservative, slightly the highest. Choose the most conservative when growth projections are uncertain or when oversize is preferable to undersize. Short answer 2. Rational method for a 23 hectare urban catchment. 5 hectares of roof at C0.9. 8 hectares of asphalt at C0.85 and 10 hectares of lawn at C0.15. Compute the weighted product. Roof contributes 4.5, asphalt 6.8, lawn 1.5, sum equals 12.8, Q equals 1 over 360 times 12.8 times 60 millimeters per hour, Q equals 2.13 cubic meters per second. Key assumptions: rainfall uniform over the catchment, intensity constant for the duration equal to the time of concentration, runoff coefficient constant, and the catchment small. Score yourself 0 to 7 correct. Revisit the Tuesday concept videos. 8 to 12 practice more numericals. 13 to 15 you are exam ready on module 2. Subscribe to Learn Civil Easy for the next module. See you on Tuesday.